evening everyone. This is K. Parvatisham. I have an experience of 10 years in teaching physical science. So let us be back to our topic. Before that, for sooner admissions, for sooner knowledge, for gaining extra knowledge on the subject, just rush to admissions and scroll the numbers to get admissions. So, in the previous session, we were discussing about a reflection property, that is reflection along with its objects, and also the rules for mirrors and also the ray diagrams for a concave mirror. We have illustrated the definition part of a spherical mirrors also. So now as a part of that, this class is exclusively for ABC channel. This class is exclusively for ABC app because no other way you are going to find this. This is out of your textbook only for the students' knowledge. That is nothing but we are also going to learn about the ray diagrams, related to convex mirror also. The ray diagram which are related to convex mirror also. Listen carefully. This you are going to obtain here only. Nowhere you are going to find. So before going to that, let us once recall the part of concave and convex mirrors. See, actually what is this part? This portion or KV surface is nothing but predictable as a concave mirror. Naturally it is predictable as a concave mirror, and of course this could be the active or reflective surface of the mirror, and the back end side is not an active portion. So against this one, on the contrary to this one, we take a convex mirror. We take a convex mirror. So what is the difference found here? Here is the active portion. This could be the active portion and this could be inactive portion. This could be an inactive portion. So I just would like to give you a small one more difference. What is that? If we are going to take the principal axis, in the inner side, that is in the concave surface, we are able to expect focus, we are able to expect pole, we are able to expect a center of curvature. But on the contrary, here at this refractive sides, this could be a reflective side and this is the active side. So you are able to expect inner portions as the center of curvature, focus and pole. On the active side, you are not going to possess any type of points. Whereas in the concave mirror, you are able to possess all the points or all the terminology in the active side. This is the main difference, my dear friends, because on this factor itself, we are going to discuss the ray diagrams which are related to convex. Right, so this is an important point. Once in 2 minutes I just recall it. Concave surface possess all the terminology, pole, focus or center of curvature on the active side, whereas the convex portion, that is nothing but bulging portion, always possess pole, focus or center of curvature behind the mirror. It is not on the active side, and of course the principal axis lies the same for both. So now let us understand what are the two cases which are related to convex mirror. So as usually my friends, we are going to discuss about 4 headings. What are the 4 headings? The first should be a perfect heading. First should be a perfect heading. Second should be a neat labeled ray diagram. Third should be the context related to that particular ray diagram. And fourth one is nothing but a characteristics of the image form. So in the same manner, let us discuss about that. Ray diagram drawn when an object is placed. Where it is placed? At infinity. At infinity. My dear friends, you can just take this point, that is nothing but at infinity we are exclusively saying about convex mirror. Because the same case is found in concave also, do not get confused. So let us prompt this one. Here I am able to take a convex mirror. For this I am able to draw for this session, I am able to draw the principal axis. And while coming to next, here we are going to expect a focus. At the same time, we are going to expect a center of curvature. Just now I have said you that this lies behind a mirror, not in front of a mirror in case of convex mirror. So what are we going to do here? Let us consider an object is placed somewhere at an infinity. We do not know the distance. Where is an object? We do not know the distance. So we are able to frame a ray. We are able to frame a ray, and of course this is an incident light ray coming from an infinity distance. And of course, according to the rules of convex mirror, what are we going to take? A parallel ray which is coming parallel to the principal axis diverges. It is going to diverge away from the mirror. It's going to diverge away from the mirror. This is a very important statement. Whereas if suppose if a light ray is expected below also from the object, somewhere it's placed at infinity. And as usually this is also a parallel ray. It diverges away from the mirror. It is going to diverge away from the mirror. So what are we going to expect? Here, are you able to expect the convergence process? No, because the ray 1 is a parallel ray which has diverged away from the mirror. Because the second is also diverged away from the mirror. You cannot be able to expect a real image, because the real image is formed by the intersection of reflected rays. This is an important. Whereas if you want to form an image, let us take, are these the parallel rays? No, they are, one is upside, another one is like this downside. So let us try whether they can meet by case of a virtual. Let us extend these rays. So on an extension, what are we going to get? We are able to get the intersection portion. We are able to get the intersection portion exactly at the focus, and here you are able to get an image. You are able to get some image. And my dear friends, you just take over this one. It is formed at a focus on the point itself, not above the principal axis exactly, nor below the principal axis exactly. It is slightly raised to the principal axis on the focus itself. Because of this reason, what are we going to discuss? The characteristics about its size. When you come across its size, how could it be? The size of this one is highly diminished. It is not small, it is not large, it is very highly diminished. Even you cannot expect with your naked eye that is highly diminished, simply you can say point sized. That is, the size is going to be very highly diminished. We are able to expect. Whereas the second characteristic is nothing but, is it above the principal axis, below the principal axis? My dear students, listen this carefully. Actually, this is point 1, which is exactly forming on the focus. But what is this? There is a chance of virtual image here, so that it may be slightly above the principal axis. If an image is going to be resulted, it might be slightly above the principal axis. Therefore, we are able to expect the position is as above the principal axis, and that can be stated as an erect position or erect image. That is an important issue here. Whereas while coming to a third, you remember about a third. What is a third? It's about a nature. It's about a nature. Listen, my dear friends, this is a very interesting topic. What is that? It's about a nature, and nature is nothing but, it is not formed on the active side. It is formed behind a mirror, and of course, it is not formed by the intersection of reflected rays. It is formed by the elongation or extended rays intersection. Therefore, the image here formed is nothing but a virtual in case. It is the virtual in case. Whereas the last position is nothing but, it is the location where the image is formed. That is nothing but a location, is a heading. Naturally, you can term this as the image is formed on focus behind the mirror. On focus. So my dear friends, as this is a ray diagram which is related to convex mirror, we are able to take two rays. What are the two rays we have traveled here? One is a parallel, and of course the below is also the parallel ray which is coming from a infinity object which could not be placed here. And therefore we are able to obtain a point size image here. Right? So let us exclusively jump to the second case where we are able to obtain similar type of a image. So do remember, my friends, we are moving on to the second case of a convex ray diagram. So let us understand first of all a clear heading. A clear heading. Ray diagram placed. Ray diagram placed when an object is, where is the object? This is an important. When an object is placed in between finite distance, or you can also term this as in a fixed finite distance. Why? Because Finite distance is a term which indicates us that finite is a meaningful word which is exact. Of course, ఇంతకు ముందు తీసుకున్నటువంటి రే డయాగ్రామ్ కేసులో మనకు వచ్చింది ఏంటంటే ఇట్ ఈస్ ఫ్రమ్ అన్ ఇన్ఫైనైట్ డిస్టెన్స్, దట్ ఈస్ వీ డు నాట్ నో వేర్ ద ఆబ్జెక్ట్ ఇస్. బట్ హియర్ రే డయాగ్రామ్ ప్లేస్ వెన్ అన్ ఆబ్జెక్ట్ ఇస్ ప్లేస్డ్ ఇన్ ఫిక్స్డ్ ఫైనైట్ డిస్టెన్స్, అంటే ఒక ఫిక్స్డ్ పాయింట్ దగ్గర మనకు ఆబ్జెక్ట్ అనేది ఉంది అని మనం చెప్పగలుగుతున్నాం. దానికి మనకు ఎటువంటి టైప్ ఆఫ్ క్యారెక్టరిస్టిక్స్ వస్తాయి? లెట్ us first draw the diagram. So let us take this as a convex surface, which is nothing but I am making it highlighted that this is the active side of a mirror. This side is the active side of a mirror. So what I am going to do, I am able to take as usually the principal axis. So I have taken the principal axis. While coming to our next one, what are we going to discuss? This is an important proportion, as if already I said that here comes your focus, here comes your center of curvature, and then comes your pole. So what about these points remain inside a convex mirror, and at that side you do not have any type of points, especially in convex mirror. So let us take a finite distance. Finite distance is fixed distance, known distance. Let us suppose it is an object placed here. And of course, an object is placed here. Let us understand how the rays are going to result. So, what I am going to do, I am able to take the ray 1. So, I have taken ray 1, which is nothing but passing towards C, which is passing towards C. While coming to second ray, I as usually take a regular phenomenon that is nothing but called as a parallel ray, which is diverged away from the mirror, which is diverged away from the mirror. So I have taken two rays here. The first ray is nothing but passing parallel to the principal axis, passing towards the center of curvature, and the second ray is nothing but I am able to take the ray which is passing parallel to the principal axis, leading to divergence against the or away from the convex mirror, that is parallel ray. So as a result of this one, we did not discuss about this one. This as an emergence, it goes in this manner itself, that is the ray itself acting as an incident light ray, at the same time it is only acting as a reflected light ray also, as we discussed in the case of rules of ray diagrams. So now what are we going to do? We are able to extend these. We cannot expect any intersection on the active side. Therefore, we are trying for a extension of these rays. And of course, the ray is already extended. The only thing is nothing but we have to extend this ray. Let us extend this ray. So, on elongation or on extension of this possible parallel ray, what is happening? These are going to intersect at this point, resulting in an image like this. Resulting in a image like this. Let us suppose this is nothing but a image. Let us suppose this is nothing but a image. So what are we going to expect here? Let us understand the characteristics now. Point number one, do not get confused. I just would like to recall this one. Here I have taken a convex mirror and of course I have placed a object in a fixed distance, that is finite distance. I do not say that the object is somewhere, I do not know. It is exactly at this particular point, and at this time I am able to take two rays. The first ray is nothing but which is passing towards the center of curvature. The second ray is nothing but which is parallel ray towards a parallel principal axis. Naturally, the parallel ray diverges away from the mirror, whereas this passing towards the center of curvature naturally deflected 180 degrees. As usually, it is bending like that only in the same path but in opposite direction. What is this? Here we are able to extend these rays as we are not able to follow the intersection of the what about reflected rays on the active side, so that we are able to try behind the mirror and we are extending this one and we are able to obtain a image. Therefore, let us try for the characteristics. Let us try for our characteristics. As usually known, we have four characteristics. The first one is nothing but called as a size. So, as mentioned, at this size, what are we going to expect? Here, an object is this much in size, whereas the image formed here is very smaller. It's very smaller. So, we can say the image size is less than object size. Image size is less than a object size. Therefore, we are able to expect the image processed here as diminished image. We are able to expect the image as a diminished image. And of course, let us go on for the second characteristic. This is nothing but called as position. So what is the meaning of a position? Check whether image is formed above the principal axis or below the principal axis. Let us understand this one. It is actually lying above the principal axis. Therefore, lying above the principal axis. Above the principal axis. Therefore, what type of image it is? It is erect image. It is a erect image. While coming to a third, what is the nature of the image? The third is nothing but we can expect the nature of the image. What is the nature of an image? Is it formed by the intersection on the active side or behind the mirror? Naturally, it is formed by the intersection of elongated rays, not reflected rays. Therefore, formed by intersection of elongated rays. It's formed by the intersection of elongated rays. Therefore, naturally, this is nothing but called as a virtual image. It is nothing but called as a virtual and image. And the last heading is nothing but its location. Where is the location? It's behind the mirror. Let us write here, location is at behind the mirror in between pole and focus. In between a pole and focus. This is the location is behind the mirror in between P comma F. In between pole and a focus. Here is a P, here is a F. So in between this one, we are able to expect this image. So these are the two varied ray diagrams which we can see in a case of convex mirror, and of course this is a convex mirror. So these are very important for your obtaining knowledge. So what about this one? Here, whatever the size you are obtaining in convex mirror is a purely diminished image. Earlier case, you studied it as very highly diminished, like a point sized. Whereas now we are able to obtain diminished image. Right, Amma? So what about a position? Both are lying above the principal axis. Of course, it is a erect image. And of course, both are formed by the intersection of elongated rays. Therefore, it is nothing but, what is the nature? Virtual. And both are lying behind a mirror. First case is formed on the focus. Second case is formed in between pole and focus. Right? So with this, we have completed ray diagrams which are useful for you also. So let us be back to the next topic of mirrors, that is nothing but applications of spherical mirrors, that is uses of spherical mirrors. So, let us go on for the uses of spherical mirrors, and of course this could be a 4 marks question in a previous patterns. ఇంతకు ముందు సిలబస్ స్టార్ట్ అయిన కొత్తలో 4 మార్క్స్ అడగడానికి ఛాన్స్ ఉన్నటువంటి క్వశ్చన్ ఇది. కానీ ఇప్పుడు ఎక్కువగా దీనిపైన 2 మార్క్స్ క్వశ్చన్స్ అనేవి అడుగుతున్నారు. సో వీటి గురించి 1 by 1 ఒకసారి మనం డిస్కస్ చేద్దాం. సో లిసన్ హియర్, ద ఫస్ట్ is nothing but applications of spherical mirror. So listen here carefully. What are the applications? Generally we say applications are nothing but uses. So how the spherical mirrors are useful? Let us understand the spherical mirrors are of 2 types. The first one is concave mirror. Second one is nothing but a convex mirrors. So in between this one, let us understand one topic uses and then the second topic uses. So point number 1, the concave mirror. Concave mirror is used as first one. The concave mirror is used firstly as a converging mirror. It's used as a converging mirror. That means it is able to emit, it is able to trap high amount of energy with its concave surface. So these are generally used in satellite or towers to trap even weak signals. So to trap weak signal, we are going to use this one. For suppose we are able to take whatever the satellite which is in concave nature, which are provided with a limit full. Even this we are able to observe in a dishes of TV cable which we have placed at the terrace. So it is going to trap even weaker signals. They are going to trap even weaker signals. Therefore, they are useful as, what about concave mirrors are shaped like this to receive converging mirrors or satellite making, or what about dishes surface making. Whereas second, these are the converging mirrors which form enlargement in the image. They are going to show enlargement. అంటే ఒక ఆబ్జెక్ట్ ని ఉన్నదానికన్నా పెద్దగా చూపించడానికి పనికొస్తుంది. కాబట్టి this are mirrors which are useful in different varied fields like shaving mirrors. అంటే మన ఫేస్ అనేది ఎక్కువ క్లియర్గా కనిపించాలి, పెద్దగా కనిపించాలి, సో దాట్ ద షేవింగ్ కెన్ బి వెరీ క్లియర్. సో ఇక్కడ షేవింగ్ మిరర్స్ లాగా యూస్ చేయొచ్చు. ఎట్ ద సేమ్ టైం ఈవెన్ డెంటిస్ట్ రికమెండ్ You people might have seen a smaller thing. When you feel a pain, automatically మీకు పెయిన్ ఎప్పుడైతే వచ్చిందో ఆటోమేటికల్లీ డెంటిస్ట్ దగ్గరికి వెళ్ళినప్పుడు అతను ఒక చిన్న రాడ్ లాంటి స్ట్రక్చర్ అనేది ప్లేస్ చేస్తాడు. హీఈస్ గోయింగ్ టు ప్లేస్ ఎ రాడ్ లైక్ స్ట్రక్చర్ విచ్ ఇస్ అటాచ్డ్ విత్ ద మిర్రర్, which is attached with the mirror, and through this mirror he asks you to open your mouth and he keeps in your mouth and then he observes what is going on, what type of, he cannot go into your mouth, right? So such a type of minute mirror with the concave nature, enlargement, పెద్దగా కనిపించడానికి concave mirror అనేది మనం అక్కడ యూస్ చేస్తే అక్కడ లోపల పళ్ళల్లో ఏమైనా డ్యామేజ్ ఉందా అది అతను అలా మిర్రర్ నుంచి చూసి ఓకే దిస్ ఇస్ ఇంజ్యూర్డ్, దిస్ ఇస్ సో అండ్ సో, దిస్ ఇస్ సో అండ్ సో, నో problem for you. Like that he is going to give the comments and he is going to give the treatment. So these are useful for a dentist also. At the same time, very important, they are going to trap much energy so that they are used as a reflectors also in headlights. Headlamps of automobiles kaniyandi or headlamps of cars or anything, whatever, we are going to extract them as reflectors because they are going to trap more energy and give immense light. So ila manaku number of uses anevi unnai. Even the concave mirrors are useful in a telescopes also to view an object bigger. పెద్దగా కనిపించేటటువంటి ప్రాసెస్ ఎన్లార్జ్మెంట్ ఇన్ ద ఇమేజ్ కావాలి కాబట్టి టెలిస్కోప్స్లో కూడా మనము ఏం చేయొచ్చు, వీ కెన్ యూజ్ సచ్ టైప్ ఆఫ్ మిర్రర్స్ ఆల్సో. So what about ila, we are going to have many uses for a concave mirror. These are just for a normal understanding. The first one is they are used to trap even weaker signals. So even a dish or satellite are made with a concave mirror surface. Second one is nothing but due to the enlargement in the image, they are useful as a shaving mirrors. At the same time, they are also useful as a dentist using mirrors for their treatment. Third one, next one is they are used as a reflectors in headlamps of automobiles as they trap more energy, and they are also useful in telescopes also. టెలిస్కోప్స్ లో ఇమేజ్ అనేది పెద్ద రావడానికి మనం ఈ కాన్కేవ్ మిర్రర్ ని యూస్ చేయడం అనేది జరుగుతుంది. సో నాట్ ఓన్లీ దిస్ ఎక్సెట్రా యూసెస్ ఆర్ దేర్ ఫర్ అ కాన్కేవ్ మిర్రర్. While coming to our next, we are proceeding on to the convex mirror. Let us understand what is the meaning of a convex mirror. Convex mirror లో మీరు జరిగేటటువంటి ప్రాసెస్ ఏంటి? What is a process? So naturally, on a convex mirror, you are able to extract a small thing. Convex mirror ko వచ్చేటప్పటికి let us draw the diagram roughly, and of course this are nothing but called as diverging mirrors. Let us take this one. They are nothing but called as a diverging mirrors. That is, the image is going to be very small. The image is going to be very small. So these are used in automobiles as rear view mirrors. They are used in rear view mirrors. For suppose, let us overcome this topic because this is an important 2 marks question. Why convex mirrors are useful as a rear view mirrors? Rear ante venakala, view ante kanapadadam. So manam drive చేసేటప్పుడు, కార్ డ్రైవ్ చేసేటప్పుడు కానీ బైక్ డ్రైవ్ చేసేటప్పుడు కానీ మనకు ఒక 2 వ్యూ మిర్రర్స్ ఉంటాయి. ఆ వ్యూ మిర్రర్స్ నుంచి మనం వెనకల ఏమొస్తుంది, కారా ఏమొస్తుంది అనేది మనం అబ్జర్వ్ చేయొచ్చు. సో వాట్ ఈస్ దాట్? అక్కడ మనకి ఏంటంటే ఇదే ప్రిన్సిపల్ అనేది వర్కౌట్ అవుతుంది. డైవర్జింగ్ మిర్రర్ కాబట్టి కాన్వెక్స్ మిర్రర్స్ని అక్కడ మనం వాడుతున్నాం. సో ఎలా కన్వర్ట్ అవుతుంది, ఎలా మనకి ఇమేజ్ వస్తుంది? విత్ ద హెల్ప్ ఆఫ్ రే డయాగ్రామ్ ఐ డ్రా అండ్ షో యూ దట్ ఈస్ నథింగ్ బట్ ఫస్ట్ లెట్ మీ టేక్ ఏ కాన్వెక్స్ మిర్రర్. So let me take a convex mirror. Naturally we are going to obtain a principal axis. So let us suppose this could be an active side, this could be an inactive side, and let us take pole, focus, center of curvature, and an object is placed here at finite distance. Let us say we are driving like this. This is my left mirror. This is my left mirror. And of course, what is this? The ray, this is nothing but some automobile or auto or car or some bike or some cycle. How should I see this? Just before case itself, we have observed that a parallel ray which is moving away from the mirror, which is focused on extension here. At the same time, we are also drawing a ray which is towards a center of curvature, It emerges in that manner. So what is going to happen here? We are able to take on an extension of this one, we say that they are intersecting at a point, and this could be an image. So once you listen that this is something car which is some behind us when we are traveling. This is an image of car. In our side view mirrors. So automatically these sizes you observe, the object is greater, image is smaller. It covers a wide area, so that we use this convex mirrors as a rear view mirrors. So that what is this? In order to get you clear or get your clarity on the mirrors, it is noted that the objects in the mirror are closer than they appear. అని మీకు ఆ మిర్రర్స్ పైన రాసి ఉంటుంది. అంటే వెనకాల వచ్చే ఆబ్జెక్ట్స్ మిర్రర్లో కనిపిస్తే చిన్నగా ఉన్నాయంటే మీరు దూరంగా వస్తుంది అనుకుంటారు. కాబట్టి ఇట్ ఈస్ క్లియర్లీ నోటెడ్ దట్ ఆబ్జెక్ట్స్ ఇన్ ద మిర్రర్ ఆర్ క్లోజర్ దాన్ దే అపియర్. అంటే అవి కనిపించేటంత దూరంగా లేవు, దగ్గరగా ఉన్నాయి. మీకు ఇమేజ్ చిన్నగా ఉండడం వల్ల అలాంటి ఇల్యూజన్ అనేది కనిపిస్తుంది అని చెప్తున్నారు అన్నమాట. సో ఇదే ప్రాసెస్ అనేది ఈవెన్ యూ కెన్ ఎక్స్పెక్ట్ ఫర్ ATM machines also. In a ATM machine, మీరు స్వైప్ చేసేటప్పుడు ఆటోమేటికల్లీ యూ ఆర్ గోయింగ్ టు గెట్ అ స్మాల్ మిర్రర్, స్మాల్ ప్లేట్స్ లాంటివి ఉంటాయి. దాని నుంచి మీరు వెనకాల చూసుకోవచ్చు. ఓకే, నేను పాస్వర్డ్ టైప్ చేసేటప్పుడు వెనకాల ఎవరు ఉన్నారు. ఈవెన్ దోస్ ఆర్ ఆల్సో మేడ్ అప్ ఆఫ్ అ కాన్వెక్స్ నేచర్. అండ్ ఆఫ్ కోర్స్ దే ఆర్ ఆల్సో యూజ్డ్ యాజ్ అ విజిలెన్స్ మిర్రర్స్. Especially at the ghat road sides, what is going to happen? Vigilance mirrors అనేవి ప్రతి కార్నర్ కి పెడతారు. దట్ ఈస్ అవతల ఎవరు వస్తున్నారు వెహికల్స్, ఇక్కడ ఎవరు వస్తున్నారు అనేది మనం ఐడెంటిఫై చేసుకోవచ్చు. సేఫ్ డ్రైవింగ్ కి వెళ్ళొచ్చు. ఈవెన్ డిపార్ట్మెంటల్ స్టోర్స్ లో కూడా విజిలెన్స్ మిర్రర్స్ అనేవి యూజ్ అవుతున్నాయి. సో ఇలా మనకు వచ్చేటప్పటికి వీఆర్ గోయింగ్ టు గెట్ నంబర్ ఆఫ్ అప్లికేషన్స్ ఫర్ అ కాన్వెక్స్ ఆర్ యాజ్ వెల్ యాజ్ కాన్కేవ్ మిర్రర్స్ ఆల్సో. సో we are terming off this topic, and in the next class we would like to go on for the next topic. Don't go anywhere. Obtain quality education through our only channel, that is nothing but ABC Education and Learning app. Further admissions, just dial to the number which is scrolled down, and it's already late. We are going to run the syllabus, so don't miss any single second of time, because my dear friends, ఏది మిస్ అయినా మళ్ళీ తెచ్చుకోవడానికి ఛాన్స్ ఉంది, కానీ ఒక స్టూడెంట్కి వాల్యుబుల్ టైం మిస్ అయితే మళ్ళీ తెచ్చుకోవడానికి ఛాన్స్ లేదు. సో రష్ ఇన్ టు ద అడ్మిషన్స్. ఆల్ ద బెస్ట్. టేక్ కేర్.